Afternoon, everyone. My name is Aaron Smith. I'm the CEO of the Energy and Environmental Building Alliance. I'm joined as always by our Executive Vice President, Nancy Bakeman. We're really excited to welcome you to the EBA webinar podcast series. This, of course, will be on the EBA Learning Management System, and this will be recorded and put out as a podcast on our Better Homes, Better Future podcast. Well, we're really excited to introduce Todd Bell and Lauren Greshel from Premier SIPs. I've had some chances to work with SIPs in the past. I just love the product. They're going to talk to you about how to transform your projects with panelized construction. Just a couple housekeeping things. We do have some AIA credits for today's session, and we'll be answering questions throughout today's in the Q&A section. So put your questions in the Q&A. You can upvote those, you can downvote those questions, and the team from Premier SIPs will answer those as we go through. Todd, Lauren grew up in the business. Todd's been in the business for 32 years. You've really got some great experts here to answer your questions today. So with that, Todd, love to turn it over to you. Thanks for being here today. Thanks to the audience for joining us, and looking forward to a great discussion.
Great. Thanks, Aaron. Thanks for the great introduction there. Hey, so what we're going to do is we're going to review how to transform your projects with panelized construction, as Aaron noted there. And so let's go. Again, a little bit of housekeeping. Again, Q&A at the end. For those of you that are AIA members, if you can email marketing@premiersips.com with your AIA number, that's marketing@premiersips.com, either throughout or at the end, and we can get you taken care of with certificates and so on and so forth. That's me. Been doing this for a little while, 30 years, and yeah. So, presentation overview. We're going to identify some industry challenges. We're facing obviously some labor shortages, rising material costs, as well as evolving building code challenges with increasing code criteria. Understand building envelope solutions, the building envelope's critical strategy, of course, and we need to understand how that impacts what we do. And then we're going to focus on high performance. We're going to highlight some of the benefits of SIPs and how they can change and work with a couple of the other challenges there. SIPs learning objectives here, off-site construction, understanding the different types, labor shortages, understanding how SIPs can impact that, labor energy efficiency and durability, how SIPs impact that, of course, and finally to understand how to get started working with the product. Construction innovation over 147 years, pretty sad statement here. We're building houses very much in the same way that we did in 1877 or even earlier than that. We made some changes to the way we insulate the things, and of course a lot of the mechanical stuff and this, that, and the other, plumbing, electrical, all that kind of stuff. But for the most part, the framing remains the same. Quality, of course, isn't, but the framing remains the same. Construction innovation is way overdue. You look at general manufacturing, cars, automobiles, and what we did with the automation in the early 1900s and where it is today. We've come a long way in general manufacturing in that scope. And as far as you look at AI, you look at computer technology, and learning how to fly in the last 150 years. All these things have really progressed. Unfortunately, construction industry has not. We've kind of done same old, and in some ways actually kind of degressed a little bit in that respect. The education in regards to the construction industry is degressing a little bit. A lot of times we use a speed square to draw straight lines nowadays when it has a lot more functions than that. So. Here's a framed project just showing you, the inconsistency and what potentially happens here.
Wow.
Yeah, that is a wow.
Yeah.
That's a nice wow picture. So building industry hasn't changed, but elements within it have, of course. The quality. The quality of the material is a lot less inconsistent than it used to be. Just because we're having to not cut down as good a material as we don't have that good material. We've used it all up, and now we're using second growth and third growth trees and that kind of thing. And we're also cutting down materials that we're trying to harvest quicker. So, and we're trying to create and make grow faster. So the quality of the material just isn't there. Skilled labor shortages, we talked about that a little bit, but really going into the skilled part, in schools, we used to train a lot about, how to create a theoretical length, how to cut bird's mouth, and then in the 60s, we created trusses, and trusses kind of revolutionized the roof truss industry for roofing. And so some of those things have been a positive, but overall the shortages and what we've had to do because of what we're facing in true skilled labor. Material costs. Material costs, of course, with inflation and things like that, and of course, lack of good material have increased dramatically, 400 or 500% in most cases. And then, of course, energy code requirements, because we don't want to create any more nuclear facilities. We don't want to create any more coal supplied energy facilities. We've really got to the point where we're increasing energy codes countrywide. Some states are really taking the lead on that. For example, California, Washington, and even over in places like Wisconsin have really taken a lead and required much higher energy code requirements. So the challenges with panelized construction, we're building envelopes as a first line of defense. We deal with better material quality. We deal with those labor shortages and budgeting and energy costs. Thermal envelopes also play a big, big play in durability, indoor comfort, long-term operational costs. It also enables buildings to meet those codes that we're trying to meet. So two primary envelope assembly options. Again, we talked about stick frame. You look at all those pieces and parts and potential inconsistencies, and it just, obviously makes a lot of sense that with the modern building methods, utilizing panelized construction that's prefabricated, pre-cut in a factory environment, we don't have to worry about wind and rain and snow and all those outside things that we can't control. Comparing assembly components. Again, this is kind of what we were talking about earlier about material. You look at the old growth compared to new growth. A lot of times when we take down a house that was built in the 20s or 30s, now a lot of that lumber is great stuff. We use it for trim nowadays, but you'd be hard pressed to find a 2x4 like you see on the left there with that tight vertical grain. And certainly if you found something like that, you'd pay out the nose for it and probably wouldn't use it for framing. Whereas the one on the right with the heart right in the center, big growth lines, that's what we're using. And unfortunately, that type of material does a lot of bad things. We've got a lot of acronyms for what a stud does. It cups, curls, bows, twists, tweaks, has wane on it. All those things are bad in the industry and make the guy after the framer have to deal with it, whether it's the sheetrock guy or the trim guy or what have you. So as an industry, we've kind of converted to engineered products. Many of them are really revolutionizing what we do. And from trusses, which I talked about earlier, to TGIs and floor systems, to PSLs and LVLs and engineered beams, They have more consistency. They're more dimensionally stable, and they don't move on you like some of the general 2x material does. And finally, you have off-site panelized assemblies like ours, where we have the insulation incorporated into what we do. We cut out windows and doors. We take care of any human imperfection through QC process, and it just basically creates a predictable on-site solution. And again, some pictures down below, some extreme examples of what wood can do. Growth and off-site construction. Well, everybody's in a hurry to get to the end, right? Whether it's a general foot race or it's building construction, when you're in a hurry to get to the end, there's a myriad of reasons for that. In this particular case, for a 7-Eleven, they want to sell Slurpees and hot dogs quicker, right? So they want to open the building quicker. And so having something manufactured off-site while simultaneously they're working on-site to create the dig out, the foundation, and all that stuff. So when the material shows up on-site, they save themselves a couple weeks and have some pre-manufactured material hitting the site. Is beneficial to them. The construction is growing very rapidly for off-site construction. We've looking at over doubling in the next few years because of the demand. Benefits of off-site construction, again, reduce labor costs. We're again creating a lot of that labor in the factory where we don't have to worry about wind and rain and outdoor environmental issues, and we can produce at breakneck speed. We don't have to worry about simple things like theft. We get to lock the doors every day when we go home. Predictable outcomes. We use computer-generated CNC machinery to cut out windows, doors, hips, valleys, plumb cuts for ease. And all those things create a predictable outcome for you when you get the product on site. Reduced waste and relative costs. When you talk about utilizing a computer and optimizing material, then what you get from that is you get the ability to shave square footage, to be more efficient with what you do. When you dump off a truck with a stack of 2x4s and tell a framer to cut it all up, he's probably not going to think every time he goes to cut the board, should I cut this board or should I cut the next board? And could I cut 2 pieces out of one board or 1 piece out of 2 boards? He just cutting away. And what he does is he creates a major amount of waste, which of course the homeowner or developer pays for, number one. Number two, goes into less sustainability. And then of course, faster construction occupancy times. We talked about that earlier. Anytime you can do that offsite construction simultaneously with what you're doing on site, stands to mention that you can, drastically reduce your occupancy times. Different offsite construction methods. You've got modular. With modular, been doing that for many years. Unfortunately, modular has minimum flexibility. You've got to be able to traditionally haul that down the road. So you're limited by the width and height restrictions of over bridges and highways and byways, that kind of thing. So limited design flexibility, but still, a good start to, getting more and more factory built scenario. Manufactured housing, and traditionally manufactured housing was thought as a cheaper way to go. And, traditionally they've created shortcuts for certain things within manufactured housing, but that's getting to be less and less of the story. They are required to meet current energy codes, and so the walls are now thicker, and they're required to meet wiring standards, and so things like electrical and plumbing are coming up in regards to codes. So the manufactured housing is doing much better. And then finally, of course, panelized housing, whether it's a stick frame wall assembly or a SIP wall assembly, the benefit of the SIP wall assembly, of course, is that it's pre-insulated also. But there's value in a pre-manufactured stick frame application too, in that it's off-site, it's predictable, it's speeds up the on-site construction. So what are SIPs? Well, SIPs are just basically a composite like that PSL, like that LVL, like that TGI. In this particular case, we laminate OSB skins to rigid foam adhesive and then fabricate. Getting more specific into what a SIP is, the structural facings are traditionally OSB. We can use different facings, of course, but OSB gives us the biggest amount of flexibility in that we can utilize OSB sizes up to 8 foot by 24 foot, one piece. So much bigger pieces, which you'll see later in some of the installation photos, but this gives us the flexibility for much larger pieces, which further expands the ability to do it faster. Strong, durable, and warranted. The foam is warranted for thermal, as well as the structural warranty for the product through the lamination. To mention in regards to lamination, we use an isoset adhesive. It's basically moisture cure. For those of you that aren't familiar with those two terms, it's like Gorilla Glue on steroids. It is once it cures, it is a bond that it will not be broken. You're going to rot the OSB skins off, or you're going to degrade the exterior skins before you're going to lose that bond. High performance and cost effective. SIPs aren't new. Here's a project done over 80 years ago with Frank Lloyd Wright design, and project is still being tested and still being checking performance. And it's now, when they didn't necessarily use OSB as the skins. I think they probably used plywood because we didn't have OSB back in the 30s, but the composite nature and the lamination was the same. And so it's not new technology. In the video here, hopefully you guys will see, it's kind of a time lapse, but it's a large commercial structure. And again, the product is coming in the form of large panels where it speeds up that construction. The use of a boom truck, crane, and or extended boom forklift aids in the assembly. And in 4 or 5 days, they've got a full structure. Below, you got some other uses for SIPs, a lot of timber frame and vaulted cathedral construction, where simplicity in design is needed, such as a shed roof design. SIPs really benefit for speed of construction and insulation above the beams. And so some other examples. Do SIPs meet the codes? Well, of course. Specifically, our company, it has the LA research report, which is one of the reports needed in LA County in California, as well as Title 24. We are also code recognized through ICC, which is, nationwide, even in seismic zones D, E, and F. It's important to note that not all companies have seismic zone D, E, and F. May not make a difference if you're in the middle of Wisconsin or Missouri and you don't have that high of seismic zone. But if you are in the West Coast or in a high seismic or high wind speed area and you need that criteria, there are companies out there that have some further robust testing than others. And it's important for you to understand which companies have that testing so that you don't go down a path with a company that basically may not be qualified for what they're trying to sell you. We also are recognized for the NFPA 285. This is kind of a new multi-story fire test for multi-story structures if you're doing multifamily, that kind of thing, as well as the wildlife urban interface. I know I'm probably saying a few new acronyms. The Wildlife Urban Interface, or WUI, as we call it, is a new fire code that is going to be in everybody's face fairly soon. So IECC code. SIP assemblies meet the section C402 and R402. What does that mean to you? That means that as we get into the 2021 and the 2024 IECC code, which will eventually require, if not already, will require the addition of continuous insulation on the outside of a stick frame building. We meet that criteria without that additional CI, which basically is another time saver and a huge money saver for you on meeting those requirements. So in a stick frame assembly, again, meeting those codes, whether it's today that you're having to deal with it or nationwide as of the 2024 code when it becomes adopted, is something to remember. SIPs deliver multiple paths to the energy performance. Most all states have two paths. They have a prescriptive path, which is basically follow these rules and you shall have a permit, or follow the performance path, where you basically look at the building, look at the values of the insulation of your wall assembly, of your windows, your doors, and as a complete assembly, you provide performance that meets that criteria better than the prescriptive path. And that's traditionally done through the U factor, which is basically the decimal equivalent of R. And it's basically a lot of math that helps you go down the performance path. SIPs are resilient, ready for natural disasters. Obviously, we're getting more and more of those in the States as the climate does what it does. Again, we're recognized in seismic zone D, E, and F. Again, not all manufacturers are. We do have some specific testing for high wind speeds. So we have some FEMA testing if you're going down that path. And then again, the WUI compliance. This is something that, again, if you guys haven't looked into yet, it's going to be in your face fairly soon, the WUI compliance. So jot that note down and kind of look it up online. It really delves into how you're going to design a project, whether or not you have the cementitious or non-combustible products used for siding, that kind of thing. SIPs are stronger. Why are they stronger? Well, they're stronger because we don't have to rely on the studs. Every last inch of the panel is laminated. So instead of a load which is compounded or point loaded on each of the studs at 16 or 24 inches on center, it's dispersed out through the panel, through every inch of the panel. So you'll note here that we have a higher uniform load capacity and even a higher point load capacity, because a point load really doesn't have to point load directly on a stud. A point load gets dispersed out to left and right of the point load. How are SIPs used in construction? Like windows or cabinets, they're manufactured, for each building plan. We create a set of shop drawings. Those shop drawings depict the way that the product is being used, the way that the product is being cut and supplied to you at the site. So we will panelize your project and supply it in those panels, pre-cut and ready to assemble. SIPs have extreme strength for load bearing, as I talked about before. And, not all projects, is probably a good point to make, is that not all projects are all SIPs. We may just do a wall assembly and use trusses for the roof. We may just do a roof assembly and use frame for the walls. If it's an elevated floor system on pilings or something like that, then we may do the floor system also. It really depends on the design and what is needed for that specific project. So how are SIPs energy efficient? Well, they're energy efficient through a number of different ways. First and foremost, they do not have thermal bridging, or at least as much thermal bridging. We still have lumber at top plates and bottom plates. We still have lumber at window and door locations, but we don't have a common stud. We don't have a king stud, if you will, depending on what part of the country you're in, whether you call it a common or king. It's a stud at 16 or 24 inches on center, which has the R value equivalency of about R6 or 1 per inch. Whereas rigid insulation in that same wall assembly has the R value of about 25. Or you're looking to the right here at a steel C-channel where even has less of an R value per inch because quite often they're not insulated in the C-channel, and it's just a great thermal conduit for loss of heat, loss of thermal performance. In addition to that, one of the things with fiberglass, or one of the benefits of rigid insulation over fiberglass, is that it doesn't sag. Rigid stays rigid, and it doesn't create convective looping. Convective looping is when the wind's blowing on the outside of the house and you get convective looping within the wall assembly, and you basically lose heat, lose air through that process. You know, if any of you've ever done a remodel, there's a reason why when you take out the fiberglass in a remodel, the fiberglass is dirty. It's really just become a furnace filter, whereas rigid insulation completely stops the airflow or air loss within that area. You still have minimal air loss, but at an average, SIPs are about 15 times more airtight than your stick frame assemblies because there's a lot less pieces and a lot more ability to create a path for air loss. R values. Again, because SIPs don't have that air loss, because they don't have an R value that depletes over time, our 4-inch SIP wall actually outperforms a 6-inch fiberglass wall. So this is shown in a clear or a whole wall scenario. And because we don't have the studs, because we have less lumber, and because we have rigid insulation, the performance level just goes through the roof. What are SIP's other sustainable benefits? Well, of course, you have long-lasting energy savings. Again, the R value doesn't decrease over time, so the R value that you have in your wall on day one is going to be that R value 20-some, 30-some, 40-some years later. And again, we provide a warranty for that. Creating healthier indoor environments. Of course, when the wind blows outside and you have a lot of air traveling from inside out or outside to in, things like fires in the area and smoke and that kind of thing, which again directly goes back to the WUI, become an issue. We've incorporated HEPA filters and we've incorporated lots of stuff into our indoor air quality, but it really starts with creating a envelope that is sealed and more airtight. Recyclable. SIP's components are 100% recyclable. The rigid insulation is a plastic product, and so you can actually grind it back down and make a new piece of foam out of it 50 years, 100 years later. So not to say that you're going to tear down a house in 50 or 100 years, but if you had to, you could certainly recycle the material. Same thing goes for the wood. The wood is recyclable, and both post-industrial and post-consumer, which means post-industrial meaning we can recycle any waste that we create in the factory, and post-consumer, of course, means any waste that you create during the construction process and or 50, 100 years down the road, we can recycle that. Obviously, from a sustainability standpoint, you can save 40 to 60% on your energy use, because the insulation works both ways, whether you're in a heating climate or a air conditioning climate. We're going to save you cost in regards to heating and or cooling the structure. And then finally, quality for environmental tax credits and credentialing. If you're looking to build a project for green or LEED or one of those different groups that are out there, SIPs definitely give you a quick path or a quicker path to get there with all the benefits that they bring to the table. Some of the environmental certifications, USGBC, which has LEED. SIPs give you a really big head start with up to 47 LEED points for that. 2030 commitment. Of course, the 2030 commitment is to potentially get to zero energy on your structures. And we just give you the ability to get there quicker and without having to build, a 2x10 wall assembly and stuff, R40 fiberglass in it. You don't have to do all this extra stuff. We can get there now with the components that we have. NAHB Green Building Program, and then finally the DOE Zero Energy Ready. All of those you can get kind of a head start with utilization of SIPs. Finally, significantly reduced embodied carbon. This is something that is also going to be shoved down our throats for good, bad, or indifferent. Carbon is important, and it's leading to, again, greenhouse gases and sustainability issues. And one of the things with SIPs being built in a factory environment is that we can control a lot of the things that typically use excess carbon. Again, we're very efficient, and we can create an end of life, less carbon emissions with SIPs. And that concludes my 30 slides. Lauren, I'm going to let you, I'm going to stop sharing right here and let you take over and go from there.
Thanks, Todd.
Yeah.
Todd, well, I got you. The question came in the chat about, why haven't SIPs been further adopted? In your opinion, what has been the holdup on, SIP adoption in recent decades, would you say?
I've been doing this for 30 plus years, and really at the end of the day, the industry has always chased the bottom line. And so my opinion in regards to that is that if you can do it cheaper with stick frame, traditionally they've done that. That's not the case anymore. With the new energy requirements and all the different requirements that are coming down, and labor shortages and cost of insurance to insure those guys out on the job site, the cost is not cheaper anymore. As a matter of fact, the cost is now swayed to where it's cheaper for SIPs. And so that's why we're seeing this big influx of business, is because, we're not the low cost. We're now the low cost provider, where originally stick frame was the low cost provider.
Yeah, builders maybe helping mitigate some of their own risk in that whole conversation. But there's been some questions that come through about pricing, and hopefully I'll be able to touch on some of that. My name's Lauren. Thanks, Todd, for sharing. I got to tell you, it's really exciting for me to be able to have Todd present for the first half of this. Todd's in the business 30 plus years. His experience is really important to the industry. He's given the industry a lot through the years. So for that, we commend him. I continue to learn from him on a daily basis. So thanks, Todd. I'm in the business 10 years. Technically, I'm probably not as savvy as Todd, but hopefully, we'll finish out here. We'll be able to provide you with some good things to think about. I'm a regional sales manager for Premier SIPs. I'm based out of Denver, Colorado. Touch on a couple of things here to finish out. We'll finish out with a few details and project profiles later on, and then hopefully have a few minutes to get to more questions, because that's usually part of these webinars that's most helpful for you. We're here for you. So feel free to keep chatting them. We won't ignore them. And Becky and Mark Yerbick is part of our team. They're answering questions as you ask them too. So I said that. Thanks, Becky and Mark, for helping out. So how do SIPs work in the field? So how do SIPs reduce skilled labor needs? Now, I'm newer in the business, a decade in. Before I even got into this business, I was reading literature 50, 60 years ago that was published. They were citing labor challenges back then in the mid 1900s. So it's not like this new issue. It's become more expensive and more important as we've come up to current time. So skilled labor is something that's almost a thing of the past, right? Prefabricated SIPs are helping curb some of those issues with that. Todd mentioned faster project completions. We've seen something as simple as our electrical chases that are in the panels significantly reduce budget overdraws by saving on electrical install. So there was a case study of a school in Las Vegas that was built that cited a significant amount of savings just by their electrical install alone in the SIPs. $1 million of savings, matter of fact. So it's pretty interesting. And it also makes us think twice when sometimes the market comes to us and says, hey, Mr. Regional Sales Manager for the SIP manufacturer, my electrical contractor is charging me more. Well, he really shouldn't be. A lot of it comes down to education. And, certainly with SIPs, it's always about education. So we kind of go back to that. We want to educate your subs. We want to educate your generals. We want to make sure the framing contractor knows the details. So how fast do SIPs install? Well, as the SIP manufacturer, we can't promise anything, right? We custom fabricate the product. We know it goes faster because our customers have cited labor savings and speed. So just by studying some data, by independent studies, by RS Means and BASF, certainly we know it goes faster. And then if a framing contractor says, hey, I could frame up that wall in about the same amount of time, well, you're still benefiting, the GC on that project's benefiting, you're getting to that dry-in phase that much quicker. So those are reasons why, you're still benefiting the project. Maybe you could frame a wall in the same amount of time as you could set that SIP wall, but you're still helping the overall project schedule. So that's what we like to see. Often the feedback we hear, significant savings. We hear framing contractors saving from 20% to 80% labor. So it depends on who you ask and the skill and crew size of the installer. So how do they get installed? We create panel layout drawings from architectural and structural plans that are brought to us. Those shop drawings are labeled. Oftentimes they go through independent PE review processes. So a deliverable for a customer would be an engineered stamped set of shop drawings. It's not a requirement. And sometimes where you're building, you don't need engineered shop drawings, but certainly comes recommended, right? You want to mitigate risk of a project. If you are building in one of those zones where building codes are pretty lax, we still encourage you to have your SIP shop drawings independently engineer reviewed. So we create large panels and as big as 8 foot wide up to 24 foot in length. That's a large panel size, and you can set a lot of square footage with one pick and set. So the simplified assembly really helps with these skilled labor challenges that people are faced with out there. Now, you still need labor on site that can follow and execute simple construction details. The SIP shop drawings have all those. 99.9% of the questions we get in the field, from a framing contractor, the answers are in those shop drawings. So that's just, something to be mindful of. Educating your builder on those shop drawings. It's an important step, right? Easy training. Most SIP manufacturers, they'll help train you up and school you up with some resources they have. We've got training videos. We've got resources. We've got our regional sales management team across the Western U.S., and we're always here to help. There's also industry resources for builder training as well through SIPA, is our Structural Insulated Panel Association. So real life examples, this is actually a 1,900 square foot ranch home installed by a crew of 3 men in one day. So I think in the SIP industry, we don't do a good enough job to emphasize the speed of assembly and how important that could be to a project schedule, and how important it would be to get to that dry-in phase before the snow flies in the fall or the winter months. So this is a kind of a big deal, and definitely we undersell ourselves probably with SIPs on how fast they can go. So real life examples, crew of 3, home set in a day. Gotta love to see that. How do SIPs affect construction schedule? There's a little bit more upfront pre-planning and design in that design schedule, that shop drawing phase that I just mentioned. We're asking our builder customers or our owner builder customers for window and door rough opening sizes, manufacturer rough opening sizes, because that can vary slightly depending on the makers of the windows and doors. So we're getting all that information, really dialing in the shop drawings. Our customer has a chance to review them and approve them. We go through that independent PE review process. And then your construction actually starts in the factory. So when you look at that schedule on the bottom, recognizing the SIPs construction schedule, you're starting that process kind of as an aside to when you're developing a site and putting your foundation in, so that SIPs arrive on site ready for assembly when you need them. So how do SIPs save time? Well, framing a wall assembly in 4 steps instead of 8, I'd say that's a start to a speedier assembly. With SIPs, you don't need continuous insulation layers. With SIPs, you don't need class 2 vapor retarder or air barriers. The SIP assembly in and of itself checks those boxes. So with SIPs, by code, it's a code-driven thing. You still wrapping a SIP wall assembly with building wrap prior to finishing. So there's still some things, and then just the connections and joints of SIP detailing I'll talk about in a little bit. So this is a unique design feature to SIPs too. Obviously, in roof design, they're providing you a full vault. And Todd mentioned this in the first half, as far as a scope of a project, SIPs don't have to be the full envelope. I mean, oftentimes we see it as a exterior walls and roof package. We won't turn away someone wanting to frame all their interior walls with SIPs either, but that's a bit of an atypical application out there. But what a full vault does with your roof design is you're creating more above square footage designable space. Maybe you design a loft or a mezzanine level where you're adding to that value of the structure by increasing your above grade square footage. You can also fur down flat ceilings and have insulated cavity spaces for mechanical, storage spaces, insulated storage spaces. You don't have to reloft your bat insulation up in your attic trusses over time. So the SIPs are a lower maintenance component and a completely sealed system. So where those electrical chases run, this is a good visual for walls and roof. For walls, you're going to see those horizontal chases run at typical plug and switch heights. For vertical chases, they're intermittent throughout that wall assembly as well. You can run wire up through the top plate if you need to access up into the roof, or from floor to floor through the floor layer up into the second floor. So there's a lot of good means and methods, training tools. We've got a Premiere specifically, we've got a nice 6-minute video that's animated that really walks you through that whole wiring process. So you can get that in front of your electrical contractor so that they're schooled up on the system. They start to understand the system and what to expect. And also too, it's worth noting, like EPS and GPS core SIPs have different electrical than like a polyurethane core SIP. So you just want to know your maker, understand what their capabilities are, so that you can understand the process when you're ordering SIPs or designing with SIPs. So how do different trades work with SIPs? Well, often we get questions about plumbing. Plumbing, you're not running the plumbing lines through the core of the panel. Now you can penetrate a SIP, create a void in a SIP for any MEP reason. Or just a small opening if you're putting a vent stack up through your roof, or in the upper wall of a bathroom that's designed near an exterior wall. Those are all things that you can execute on. You can run plumbing lines up through the floor as needed at the location. You can run them up through interior walls. And if they're near an exterior wall, the only difference is in a lot of regions, you're not designing plumbing lines going through an exterior wall anyways. I'll see it from time to time, even in Colorado, where they do design it that way. Well, then the recommendation is just a fur-in detail, that you see that typical plumbing fur-in from the wall. If you've got sprinkler lines in your roof, there's a typical fur-down detail for that if you're trying to hide those lines. You know, same goes for canned lighting. We get a lot of questions in the SIP industry about canned lighting with SIPs. You know, just for your ceiling down, those shallow LED cans that exist now, it's pretty simple to execute. And it gives you 100% flexibility with locations of those and wiring of those. So those fur channels can come in handy. So the HVAC side, on the HVAC side, essentially the feedback, and this is common, it wouldn't be like an absolute, but oftentimes the system is half-sized, because you see the data there with stick framing, an assembly, an HVAC size can handle 1 ton per 500 square foot. With SIP residential design, 1 ton per 1,000 square foot. So essentially you're getting more bang for your dollar on the mechanical side. It's good to engage with proper mechanical spec with SIPs because of how airtight of an assembly it was. You know, Todd went through some of those numbers earlier. You know, we often see blower door test scores of 1 or less on the ACH 50 scale. So it's all really important to get proper mechanical spec. And, you know, there's one of those ancillary cost effects on SIP construction versus stick frame. When you're budgeting material cost analysis, you got to look at some of these ancillary cost effects like mechanical. You got to look at waste savings. You got to look at the labor component. And then the fourth, and probably the unheralded one, is performance, long-term performance, okay? So how would SIP save on upfront construction costs? So you're essentially mitigating on average 80% less lumber. A true SIP does not have studs in the panel. If we need to, we can add shear to a wall by adding some members in it. I'll talk through some of those means and methods when I show you some of the detailing. But in roof design too, for instance, that SIP roof, there's a number of different spline methods that a lot of the major SIP manufacturers like to use. Well, discuss those and the structural implications of your spans that you're designing with the panels, because the less members that we have to stick in a roof panel assembly means that roof panel assembly is going to be higher efficiency and lower cost in the end. So just understand there are some design considerations with SIP roof and spans and loads, snow loads for where you're building. That's all an important part of the conversation. And when you're designing, you know, design considerations, we've got some good literature on design considerations, a whole packet of considerations to make if you're trying to school yourself up on SIPs. Some of you who are on this call might be able to teach me a thing or two even. So what are typical SIPs job site waste savings? Well, you can see some of the numbers here. In residential construction, I'll tell you about a case study in Golden, Colorado. They used SIP walls on a 2-story home. They used trusses on the roof. And so just using the SIPs for the exterior wall package, it mitigated 2 dumpster loads of waste off haul. So they were pretty happy with that. That right there, the off haul costs were $2,000. And the GC also told me, he said, Lauren, I was also paying the labor to fill those 2 dumpsters, and not to mention all the material that were in those dumpsters typically. So that's just something there. These case studies of waste savings is probably not talked about enough either. And then on the factory waste side, we're not zero waste facilities by any means, but we get close because we can actually repurpose a lot of our trimmings and offcuts. And in one of our facilities, we actually make EPS products. So the EPS are big vertical vacuum block molded methodology and how you make this material. And there's other EPS products that we can recycle foam offcuts back into. So it's pretty unique process that way. You can feel good about the fact that EPS is recyclable, and it's one of those few rigid insulations that have that recyclable component to it. That's why you see it in a lot of packaging. Post-construction cost savings. So some of those quality issues that you run into in the field that are creating callbacks, a lot of these can be mitigated and reduced by using SIPs. Nail popping, drywall cracking, stucco cracking. SIPs are very rigid product, and that skin of the panel is fully laminated to the foam core. You're not going to see any shifting after it's installed. By all means, that product's been set up. So it's a beautiful thing. That picture on the left of an out-of-plumb wall, that's kind of a disaster. But you see that with conventional wall framing out there. As far as tax credits go, my understanding, some of these credits and incentives are existing through the end of the year. Aaron Smith might be the better source for info on this, but I know some builders and developers are still taking advantage of 45L, 179D out there. Some of these programs might be fleeting after the turn of the year. So, cost summary. This was done by an independent party from us. This was an actual project, and I apologize because it didn't all load up there. But you can start to see the cost stacking of a 2x versus a SIP in how they analyzed all the estimates. This was going into the same project. So basically, beyond the material cost, you've got your hardware considerations, your finish considerations, drywall application on top of SIP. That using SIP, you've got an interior sheathing, which is atypical. So you don't have to fasten into stud locations. It helps speed up drywall assembly, and it mitigates drywall waste, actually, while we're on the topic. But your HVAC, your general conditions and waste, the cost of money, and then the big kicker, the graphic didn't fully load there, but the big kicker is the performance value that SIPs are bringing to the forefront of a project. So this is the real life cost comparison tool in the SIP industry. We've been pushing it a little bit because we have that misconception out in the market that SIPs are more expensive. One of the questions that came through in the first half of the presentation was about that specifically. We know that we're not exorbitant in the cost realm. We know we stay really competitive with stick framing, any stick frame assembly, let alone one that's an assembly that's built to compete with SIPs more on the performance level. We know we even have a bigger advantage against that assembly. So really, I can't stress enough, you got to look at some of those ancillary costs. And this is a little bit of a case study, 3 different comparisons of real projects that went. And when they look at straight materials, this first example is a good one. Straight materials only. They're looking at stacks of lumber, your insulation, your sheathing versus a SIP estimate and the small amount of lumber that goes with a SIP install. So you look at that outcome, SIPs are showing a lot more expensive. Okay, there's your misconception that's out there. Now when they applied true cost comparison methodology, adding labor, trade, time carrying costs, tax credits, increased value that SIPs are bringing to the table. And this is the same plan. Now we've lowered that delta. SIPs even being a 10% premium, some people out there are like, this is a no-brainer. I want to use SIPs. They're higher performance. I know I'm going to, even if that is the case. Now when you optimize a design to SIPs and taking advantage of that additional value, that above grade square footage that you're adding in, no truss framing, increased conditioned living space square footage, SIPs are showing value as far as that comparison number 3 outcome. Now, a couple other examples. This one's unique because these were already SIP optimized design. And you can, instead of me walking you through this, you can see once they applied true cost analysis, it flipped the script. SIPs were showing a crazy amount of savings just when they started figuring in true cost, these ancillary items we keep discussing. Okay. And I know Aaron will appreciate this one, being a Minnesotan. But
That I actually built that project, Mark.
Yeah, oh, I know you did.
Yeah.
I wasn't going to blow your cover if you didn't want to say,
no.
but
Anybody has any questions?
yeah. So this was 2 buildings, 54 living units. Hers rating of 45, 1.35 ACH 50, extremely tight multifamily building here, and SIPs are showing value even after a true cost comparison. They were already SIP optimized in their design. So the moral of the story is you got to do the digging when you're costing SIPs versus stick frame. You got to do it. While energy savings is key, how else do SIPs benefit the end user? So you've got operational benefits of SIPs. They help protect against insects and weathering. They also help protect against moisture. It's a completely sealed system. And there's some makers out there that use a zinc borate treated OSB or a frame guard treatment that we had mentioned in the comment section already that help further protect the material from mold and mildew. Consistent temperatures throughout the buildings, from room to room, from floor to floor. Being in a SIP structure is unique. Also, you have the STC rating, the sound rating of SIPs. I was in a bank when I was new in this business, a bank that was built out of SIPs. It was right by a highway with traffic coming by at 55 miles an hour. Literally, it was the traffic lanes were 6 feet from the wall of the bank, and you couldn't hear the cars going by. So I thought that was pretty unique case study and example to share. But other examples out there, this 35,000 square foot youth treatment center in California, this had a blower door testing score of lower than 0.5 ACH 50. It achieved net positive energy. The building generates more energy than it consumes. You're lowering a carbon footprint by keeping these operational costs really tight with SIP construction. Another good case is this charter school in Missoula, Montana. This is a 7,000 square foot school, and you see the projected energy modeling costs versus actual SIP's energy cost. They built it out of SIP walls and roof, so they'd achieve 81% savings over projected heating cooling costs. And we know this because the asset manager was excited. They were sharing their energy bills with us in the middle of winter and how it was performing. So that's how we know. What are special considerations for SIPs to be aware of? So when you're getting started with SIPs, pre-planning is key. Collaborate with a SIP manufacturer, understand their product, discuss your needs with them. Select right panel thicknesses that will correspond to your code requirements where you're building. Because often us as Premier, we make 5 different standard thicknesses. We have 2 rigid insulation core options. And so there's a lot of options that exist. Well, you want to pick the right panel to execute with. You can convert any conventional floor plan to SIPs. I mean, SIP wall framing, when we go from traditional stick frame to SIPs, it's very much an easy one-to-one swap. If you're designing a roof that's designed with trusses, you might have some VE redesign effort to figure into your design if you want to incorporate SIP roof. So specifying any custom details or mods, once the plans are finalized, SIP manufacturer proceeds into that shop drawing phase and then fabrication after that. The details that I referenced, here's some typical ways to connect panels. On the left, you've got a type S spline, or it's known as a block spline or a box spline in the industry. That's a very thermal efficient way to join panels. You also have, if you need added shear in a wall, or if you got a point load, that type L spline on the right, or you could get into a 6x6 column or an HSS column hidden in that wall. Well, most of us in the factory, most of the major manufacturers will pocket the foam back according to however big that column has to be. In roof and floors, you see that type I spline getting incorporated into panel assemblies if we need to increase our spans or loads. When you're coming up from concrete, you've got a treated plate and a bottom plate. So that treated plate is important because we can't bear our OSB skins on concrete. And so that's going to help protect that OSB skin long term. You've got other details here. Your your floor systems that you're building on top of, or your floor to floor details on the right. You can stack frame your floor, you can hang your floor. There's lots of different ways. We kind of take the lead from what's been designed, and SIP manufacturers can make some suggestions to you if you need us to. But we kind of take the lead from architectural and structural plans first. So our details are out there, they can be referenced. Typical plates, typical corner connections, lapping and butting panels at the corners, your fabricated openings, your window and doors. When we can cut them right out of a panel assembly, we will. But if we have to header an opening, it's kind of a trimmer and a king stud and trimmer type of detailing, very similar to stick frame, just hidden within the edges of the adjacent full height SIPs. Various wall to roof connections, various roof or floor plate type of details. Most of us have the ability to plumb cut your eaves if you've got a pitch of that roof line that you're trying to match into your eave. So there's kind of some various things that we could do and incorporate in ridge details. And now we get into some of the project profiles. And I know I'm getting short on time here, and so we could open it up for Q&A as I kind of casually scroll through these.
No, I think that the pictures are so great, and it's really impressive to see the different types of projects that your team has worked on.
Yeah, this is an American Indian Hall award-winning project in Bozeman on MSU's campus. Now we're seeing kind of a lot of here's SIPs integrated with steel here on this job, and SIPs integrated with steel on this project as well. So that, we're seeing a trend of that. This is
it's kind of, once you say the old days, Lauren, like everybody understood, oh yeah, I do a timber frame cabin and I throw SIPs on it. And I think there's been the shift of people understanding that if I'm doing steel frame, I can just throw SIPs on it and it's really quick to do.
Yep. And here's a profile of a timber frame project where they often clad walls and roof in SIPs. We sometimes get pegged with misconception. Oh, we need to simplify and box and do boxy designs with SIPs. Well, here's one. We've got some simple shed roof planes, but it was beautifully elegant design based on where they were building, of course. And we can get quite complex with roof design too, like these large dormers on this chapel here. I mean, so long as it's structurally designed for properly, we can make the panels for it. So
yeah, fantastic. Well, I've got a couple questions that we can go through. I think, Lauren, one of the things that I have a question on is fire rated assemblies. Typically, as you look at commercial buildings, what can you do for a fire rated assembly? What are your ratings that you currently hold?
Well, so coincidentally here, I'm on the Snoqualmie Pass Fire and Rescue building that was built with SIPs. Fire ratings, we can, you want to check with the manufacturer you're working with. Premier SIPs specifically, we can obtain up to a 1 hour rated wall and roof or floor assembly. And the means and methods to achieve usually are dictated out in a code report or tech information by that manufacturer. If you just need a thermal rated barrier, there's means and methods to get that typical thermal rated barrier versus a 1 hour assembly. So we can achieve it.
Fantastic. What about Miami-Dade?
Just to add on to what Lauren was saying, the cool thing about SIPs in a fire scenario is that, obviously we don't have to have fire blocking because we don't have all the air that's in the wall assembly is encapsulated. So there's no chimney effect in the wall assembly, which gives us a higher advantage. The second thing that gives us a higher advantage, of course, is that we have sheathing on both sides, whereas a traditional wall is open to the inside. We have sheathing on both sides. So when you put that layer of gypsum or sheetrock in addition to the OSB that's already there, you have 2 layers of protection rather than 1. So you basically SIPs just in their, in their raw form are much more fire resistant than your traditional framed construction.
Great, thank you. How about Miami-Dade hurricane? I know you had shown the Florida label that you have, but what are you seeing? Miami-Dade's a little bit more stringent. Anything, any updates on Miami-Dade?
Well, I mean, it's I can talk on that, Lauren. Basically, it's just a wind speed test. I just finished 2 projects in Antarctica where we're dealing with 180 mile per hour sustained winds. And so, what does 180 mile per hour do to a 2x4 lane on the ground? Well, it takes it takes it in the air and throws it at the building like a projectile, right? So while we have testing for that, it really just depends on your specific area. We do have Miami-Dade testing, but it's all just based on the engineering and the criteria that we have in that specific area. We'll determine, what can and can't be done with the product. There are some areas where, you just can't get to there. You can't get there from here. If SIPs are going to be the product of choice, you would need to put some sort of cementitious or wood or non-wood clad siding on it that would be more robust from a cladding standpoint. So it's also mixing and matching different products to create a system.
That's great advice. One of the questions was, you have OSB skin. You mentioned that you have other skins. I'm going to make it a 2-part question to your decarbonization slide. Are you seeing more folks try the below grade SIPs for basement walkout type of structures?
We can look at that. It's an all-weather wood foundation type of panel you're referring to, Aaron?
Yeah.
And I know we've made them. The thing is usually it's got to be a certain spec, and it's got to be engineered kind of before we start diving into making panels for it. There are companies that exist that almost specialize and do a lot of those. We are not one of those companies because most of our SIPs are for above grade applications. It's untreated OSB that we source in these big jumbo sheets. So that is a good question. We actually field that question a fair amount, but we would look at it, but the engineering would have to be done on it before we even estimate it.
It's a logistic answer too. For me, being in Seattle area, I'm not really interested in it for the reason
you don't have basements.
That
we live in the ground here in the Midwest,
Exactly. That plus the water table is much higher here in the Northwest. And so, wood and water, whether it's treated or not, don't mix. So, if it is treated, it's just a longer term until the wood rots, right? I mean, I could talk to many people that say, well, oh, I've got treated lumber. And I'll say, well, it'll still rot. It'll just take longer.
Right, sure.
And so it has to be combined with really good design that keep all water flow away from the foundation wall system. And that's a big part of what we do. And so because we don't do it as much of our business in the Midwest, a lot of our business is West Coast and basically Missouri West, then it's just not as we just don't do it as much. Yep. So
sure. Talk to me. I live in climate zone 6. Let's say I'm looking at designing a SIP house. Should I go 6-inch or 8-inch? And if I just upgrade to 8-inch, what's the nominal cost to do so?
That's a good question, Aaron. And it based on climate zone, it depends a little bit on what building code you're on, probably. That's right. In addition to the climate zone. So we, all over the country, we see building codes that are range from 2012 or all the way up to 2024, 25, these amended 25 codes that some areas have adopted. So yeah, if you just making kind of a blanket upgrade to like a 6-inch wall with EPS core SIPs, and you're jumping up to like an 8.25-inch thick wall instead, there's probably depends on the maker, but you're probably around like a 10 to 12% delta potentially in cost. So
yeah.
The other thing you'd want to the other thing you'd want to look at though, Aaron, is maybe converting to a different foam. So
Yeah.
my solution would be, especially based on the fact that it costs money to ship product from point A to point B, and volume of 8-inch is obviously more than volume of 6-inch panels. Maybe converting from a 6-inch EPS panel to a 6-inch GPS panel would solve your problem in the very same way.
Yeah.
And allow you to also look at less of a jam extension. Top and bottom plates are not 2x8, so you have some ancillary cost savings throughout the project. And the thinner wall with the higher value also gives you more inside room, more square footage. It's minimal. It's only a couple inches, but it's a couple inches around the whole perimeter of the house.
Right.
Yep. I had somebody build with 4-inch GPS walls just for that reason. Just recently, they built 4-inch GPS because they were on an older code. They could still get away with what the GPS core product was giving them, and they built it in 4.5-inch panels.
Nice. Tell us where your factories are. And I think one thing you brought up is about, there's some shipping costs to this, and it's there's probably a radius where it makes sense around each of those factories. Can you tell that to our audience a little bit?
Yeah, we've got good brethren in the SIP industry. It's a small world. We know each other. We like each other. Some of them might even be listening. So shout out to some of you. But certainly our factories are Belgrade, Montana, and Puyallup, Washington. So those are our primary manufacturing locations. As Todd mentioned, we serve the Western U.S. more predominantly because of that reason. Freight cost is something that we'll ship anywhere. Any SIP maker can ship anywhere. We don't have designated regions, but certainly freight cost comes into play, and people understand that. They want to work with their regional maker typically, and we respect that. And we want to be open too. If somebody came to us with a lead in the Midwest, we'd say, hey, there's maker XYZ and this other maker in the state over, you could check them out too. So
that's great.
Yeah.
So there was a question for me within the conversation today, and I'll go ahead and answer that now. But with the new act, the $2,500 rebate for Energy Star homes and the additional $2,500 for Zero Energy Ready home will expire June 30th of 2026. The house has to be sold or rented before that date. Those are still in effect. But I think if you look at where we live, I'm in Minnesota, Lauren, you're in Colorado. There are some significant programs through Xcel Energy in those territories where I think if you build a really great house, you could be looking at $18,000 or $21,000 in total rebates. Washington State has some great rebates. I think that we're just going to see, it back to how it was before the rebates, and that there's great rebates.
The federal
available.
rebates.
Yeah, the federal rebates are going away, but there's great state rebates.
I was supposed to mention that, and I didn't mention that. I apologize that, even though the federal rebates are going, a lot of, like here in Seattle, we have Puget Sound Energy. They have an amazing amount of rebates through our local, county and through the local Puget Sound Energy and that kind of thing. So you got to look more locally for your rebates, but there's still a lot there.
Couldn't have said it better myself. Well, gentlemen, thank you so much. Always great to learn more about SIPs. I put a couple things in the chat for the audience, but come visit us all. We'll be together, St. Paul, Minnesota, September 17th through 19th. You get a chance to see some premier SIPs in the wild. Also, the EBA Learning Management System has the SIPA Certified Master Builder training on there, I believe at no charge. So you can take that there as well. And if you get a chance, go out and see one of these go up. I've had a chance to be out on some different sites and see these, and it's incredible. I mean, it's just really, it bends your mind having grown up with in the industry of like, wow, this is, it's just amazing how fast it goes together. So, well, gentlemen, thank you so much. Thanks to our audience. If you're like us, stay cool. Yeah,
Appreciate you having us, Aaron.
All right.
It was
you
great.
bet.
Thanks again,
All right,
Aaron.
thanks everyone.
Bye-bye.
Bye.